everybody. So I'll get a good break, a little bit of time to relax, maybe practice coding, because this is an active subject we learn by doing. And well, over the last couple of weeks, which was module 3, really, we talked about some fairly important concepts, but we're always looking at just the syntax because this is a classroom setting and we're restricted for time. So I wanted to do an example of things in all those things we looked at in the last week in a finished setting. So a finished piece of software. What I intended to do that last week before the break, but I wanted to do something kind of short that night. So I come up with an example that would use just about everything. And I also thought I would show my notes here if the camera can see them. It's kind of blurry, isn't it? How does this work? Is this plugged up? I'm not sure which camera I should be using here. But I think this just came out automatically. Maybe if I walk back here a little. Oh, this is why you.
So maybe
I think that's you. When I zoomed in, it lost all sorts of, can't really see it. Oh, actually, it did switch to the other camera. Can y'all still hear me on the Zoom call?
Sure can.
Okay, I guess it did switch to the other camera and I just didn't realize it because the camera just froze up and I wasn't up there moving it, but so it should be this one. There we go.
Yeah, there we go.
I thought I would show my notes for the thing here because in a bunch of our assignments.
It's upside down on our end.
Oh.
Thank you.
Okay, yeah, I never used this. I never used this. These little overhead things. But in a bunch of our assignments, there's things like draw the UML diagrams, and we always have that nicely formatted one. We go to something like draw.io, make it look really nice and all that. But when we do that, it's hard to see how it's useful as a tool when putting something together. So on the notes I scribbled down here, you'll see kind of the basic idea of a UML class diagram, but just some very rough, messy notes. And you'll see how that can be useful as a planning tool. Only wrote a couple methods out. The method from the interface, I just wrote a $sign where that's going to show up. Our example, the working example to tie all those things together into a situation is going to be a pizza ordering thing. We'll see how time goes after we get the classes made. It'll probably be menu driven in the console, but if the parts at the top come together quickly, you can probably put it on a web page or some sort of HTML form. But I wanted to show that because when those things are thrown together as a mess, we always see that nice polished version in textbooks and stuff, or for your homework assignments, you're doing fancy versions. And it's kind of hard to see the usefulness of it there. But as a planning tool, when it's just random thoughts scribbled out really quickly, and you're only writing down the important parts instead of every single method that that class is going to have, it can be a very, very useful tool for organizing things. So I wanted to share that, and we're going to get started in this, which actually I can probably take a screenshot of that. No, it's not going to fit in there. to avoid writing that on the board, yeah, the main doesn't really say anything. If you want to take a screenshot of the plan there, I'll leave it there for about 3 seconds before I switch back to the camera and get started. That way you can see what the basic plan for this evening is. Is it backwards though? Okay.
No, it's reading correctly now.
Okay. On my screen, it's showing backwards. I guess it's because of that, the mirror option.
Oh, okay, yeah.
Normally on Zoom, we're looking at the camera and it throws everybody off because we're used to looking at ourselves in the mirror. So they added that mirror option because so our own faces don't look confusing. It's like this doesn't look like my own face. See that in the mirror all the time. So that's the idea. A pizza ordering system. A fairly simple example. Hopefully everybody kind of sees what's going on. It'll be fairly small, but see a situation where all those pieces tie together meaningfully instead of just looking at the syntax form. And then on Wednesday, we'll extend it, or not Wednesday, on Thursday, we'll get started into my SQL stuff. Which also includes what do we do when something's not part of the official installation of the Java programming language. There's a lot of databases out there, right? There's a lot of SQL databases, there's a lot of relational databases, and a whole lot of non-relational databases. So the options when they put the programming language itself together is it either include something for all of them or not include any of them. And obviously including something for all of them would make all of the projects bigger, not just the ones that need the database stuff. So we have to bring in an external library. So it'll include that. That's something we see happens quite often, just not in a classroom because classrooms we're very restricted for time. So we'll get into that, but first off, our example here, you all saw the little UML diagrams and hopefully looking at it like that, you can see how the usefulness of it, because when we have those nice polished versions, it just seems like a tedious extra little bit on the homework. It's like really, really useful as one of the messy steps in the planning phase. So we're in NetBeans, start a new project. I'll just call it pizza. That sounds like a good project name and a simple pizza ordering thing, but really it's just to see all of our stuff joined together. And take a look at all the stuff we've seen. So here's the main, which and most people starting out a program probably immediately think, okay, jump in the main menus, jump in the main function, start doing stuff. But for Java, we really need to get all of our classes together. So the main often ends up being one of the last things we do. And also the main is just one of many places we can run that same code. That's just a setting where our code can run. So the less we do in the actual main method, the better it is, because then it's easier to switch to another setting. Like instead of a console output, or if we looked at GUIs yet, having a GUI on the desktop, switch over to a web page, or switch it over to a phone app. That seems like a better place for a pizza one. People are often going to order pizza as a spur of the moment decision. They're out running errands and starting to get tired and suddenly realize they're not going to feel like cooking when they get home. So they just hit up one of the pizza places and pick something up on the way home, or tell the delivery driver, ask for the delivery driver to be there about 10 minutes after they get home or something. It's often a spur of the moment decision, so a phone app would be a good one, or a website. And we don't want to write the same code over and over and over again. And since the main method is just this one of the many settings we could run it, this is where we run it directly in a Java virtual machine on a particular desktop, separate from a network and things. Not necessarily across the network. So we want to minimize, so really all of our logic should be somewhere else. And the only thing that goes here is the one line that starts it. So I'm going to make I'm going to start with that. So I'm going to make a new class in the package called order. And then the only thing our main is going to do is create an instance of that. Order O equals new order. And we'll probably have some stuff to put in the constructor before long, but that's going to be all that goes in the main method, because it starts that and all of the other logic starts in that other place. So when we go to a web page, all we have to do is run that one line and all of the other logics. And the only difference is where we started. As this comes together, we'll probably have some stuff for the constructor to put there. But actually placing the order is going to be one of the last steps. We need the stuff we're going to order. And on that picture I just showed, well, one of our main things is obviously going to be the pizza pie, which when I was planning this, I quickly realized that the project itself was going to be called pizza. So the next best option for the actual pizza was to call it pie. It made sense in my mind. When I was preparing it. But that's just a name. We can name things anything we want, right? And there's a few things that we know it's going to need. One of those being a price. All of our pizzas are going to be different prices. And you might remember from that picture, I did two different ones. There's the regular ones. So I just, for the picture, I put pepperoni, cheese, and supreme. But there's a lot of just standards that people would order that would have a fixed price. But there's also custom pizzas. People might want something particular. Maybe somebody wants green peppers and pineapple, and another person wants half sausage and half pepperoni, but they don't want them to mix on their pizza. They want to set just one meat on each piece that they grab. So we have those predetermined ones or the custom ones, and they would be priced different. But one thing we do know they'll have in common is both of them will have a price involved. So that's a good place to just set up a rule in advance, an interface, so that we put our pricing data in one place separate from our other objects. In the long run, we'll implement an interface which brings that method into our object, but when we use it as interface data instead of object data, we only need that tiny piece of our object. Hopefully that made sense. At the introduction level, it's really hard to see where interfaces come in useful. Usually at the introduction level, we introduce it as an interface as a list of rules our objects have to follow. What I call it in my notes. Excuse me. I'm gonna make an interface called pricing. And basically just put one rule in the pricing here, and that is that anything that does this needs a public double method. It's returning a price, so we obviously need a floating point number called calculate cost. Oops, that's supposed to be an interface. I clicked the wrong button, sorry. I think I said interface, but I accidentally clicked the new class, but that's just the template that pops up. Just change the word class to interface. You did the same thing I did. Let me hit undo. If I undo that, I accidentally created a new class. But oh, it's control one, not redo. I meant to create an interface. I just clicked the wrong button there. So that gives us any pizza pie that somebody orders, we know we will have to calculate the price, but it's going to be calculated differently depending on what it is. The predetermined ones, like the one topping things like pepperoni pizza or cheese pizza, or the predetermined things with lots of toppings, the supreme, meat lovers, they're going to have a set price, whereas a custom one's probably going to depend solely on what the people put on it, what they order for it. But we know everything will have the price, so here in the parent object of all of our pizzas, we can go and implement that pricing interface. I spelled that wrong again. Yeah, I did. Yes. There we go. And I think when we saw this earlier, we just automatically put that method in there, or the method. But at this point, the child objects of a pizza pie, we'll know what the price is, but at this point, we don't know what it is. So we will need to declare it abstract. So we can either implement all the methods or just make this one abstract, which again is just typing that word. But computers are better at typing than humans. It's good to use that predictive text and autofill as much as we can. So now there's a few things that we know for certain about every pizza. It's going to have some sort of crust. And that was what I put in the little plan for a short list of things, because there's not an infinite amount of crust options when we order a pizza, right? So that'd probably be a good example for an enum. Enum, I'll call it crust. And this just gives us a place where we can make sure we're always restricted to that short list of things. What do we have? Be a thin crust, deep dish, hand tossed. I'll go ahead and put gluten-free on there. That's a common one. But it made a finite list of the options. So now anything there's only those options for it. You can't just type things in. When it comes to GUIs, that fits really, really nicely in the drop-down menu, because we don't have to fill in the drop-down menu either. We just, when we make the little, put the widget on our GUI or component or whatever we call it for the particular package, we just say, look at the short list, and then that's what goes in the drop-down menu. Save it. It'll save in a moment. So that's something we know all of our pizzas are going to have. They'll have a private data involving the type of crust it has. I'll just call it that. Every pizza is probably going to automatically have sauce and cheese, right? That's what we would normally think. unless somebody's lactose intolerant or or gets their pizza without sauce. The no cheese one I know, but I remember working in pizza places and it seemed fairly, it wasn't uncommon that people would order pizza without sauce. And I don't know the reason they would do that, maybe allergic to tomatoes or something, but pretty much all of them are gonna have it except for a few random examples. Yeah. That sounds about right. It never made sense to me. So as far as cheese and sauce, that would probably be that'd probably be good as a bouillon. We don't need the whole separate options like we would on other ones. We can just put a bouillon for has cheese, or yeah, if we call it cheese and sauce, then when we make our gators and setters, it will automatically name it has cheese or has sauce. Or NetBeans will probably call it is cheese or is sauce, but we can change that. So we'll probably want those on our pizza. Private bouillon, cheese, and a private bouillon sauce. Our other things would be more specific, right? Some sort of toppings. But we don't really, there's going to be various types of toppings, right? So we could make a short list of it, but there's different ways to approach it. And what I was thinking is different toppings might come with a different chart, different cost. So I was thinking an object for each one, and we'll just have a small number of objects. So we'll have another abstract class called topping, and then we can use that data type and have a bunch of child objects of that for the particular toppings. Pepperoni, pineapple, mushrooms, a bunch of the standard ones. So you can see the classes are going to add up quickly. Then we can do things like toppings can also implement that pricing interface. So one of the things they have to do is include how much that particular topping is going to add to the pizza. So even though it would be using the same method, it would be used differently, if that makes sense. So kind of setting up the structure here. If you can't tell, I am a little bit worried about running out of time because I don't want it to take forever. So that's why I was thinking, okay, we'll set up the structure, start making classes, get started in this, and then finishing it out will make great lab time and practices. It's an active subject. Learn to code by writing code, not necessarily by listening to me talk about code. Topping. I really need to go in there and change that template instead of just deleting these every time. But not hard to delete them. And again, each topping, I'm going to go ahead and say each topping is a different price. I don't think that's how pizza places would really handle it. That was just my solution for seeing that same interface used different ways. It's something that's not necessarily uncommon to do. The calculate price in pie is going to need to calculate the price in topping, or call the calculate price in topping. So that gives us a way that those two things are guaranteed to interface together. We know we have a connecting point between them. Both of them have to include something about their cost. Kind of like a plug. This is a hardware sort of interface with a little plug on my laptop. I know I can take this anywhere in America and plug it in. It interfaces with any electrical outlet any one pin electrical outlet in America. That's what an interface, just like the name it says, is the virtual version of that. So we use it to connect things together. And again, topping in general is, whoops, not that. Topping in general is probably going to be abstract. And then all the child classes of topping would be concrete. Like we know that in something bigger than a classroom example, the topping might have weight involved, or in a big full-blown restaurant example, it might tie into the inventory database. So we can keep track of how much it is, but tie into cooking time and stuff like that. Y'all can probably think of a few other situations as far as like the overall big picture that could not possibly fit in a classroom setting, where we know a bunch of things about our toppings, expiration dates, and all of that stuff, have all of that data handled here. And the things they're going to have in common go in the parent class, and then the child class is what's going to actually implement the pricing one, because then we'll know whether it's a green pepper or pepperoni, which I'll go ahead and make those. What's that marked? Is there? Okay, just hadn't compiled yet. So that's probably a good first couple examples. A new Java class, pepperoni. And I always go ahead and type it in, but down here in this interface, notice there's these options to choose what superclass it's going to connect to, what interface it has, and all of that. When we connect to the particular that parent class, the interface, it inherits that need for that interface. But we can just choose from these boxes as well. I don't know why the stuff that was already in the package wasn't automatically there. Again, pepperoni is not abstract, and it doesn't implement our method, but we probably know how much pepperoni would add to a pizza. Does anybody have any thoughts on that? I would never pay attention to the pizza place. Is it $1 a topping? Does that sound $1.25 a topping? Yeah, when I go into a pizza place, I just start ordering stuff and then hand them the card. It's like, yeah, oh, that and that and that and that here, whatever it costs. $1.25 sounds is a guess. It'll work to test our program. So we go ahead and implement the abstract methods. Calculate costs. This is just for adding pepperoni. So all we need to do is return the price of that, which would probably be better as a data field, right? Private double price. Well, actually, I'm just gonna put it in as a magic number. Nobody here is brand new to coding, so you all know that would be better as a variable or a data field, right? I think everybody's aware of that, but we have to make some adjustments because of the time restraints in the classroom. And if we put it in as a data field, then we would need constructors and all sorts of things that, or it would essentially be just a magic number with a name put to it. Might as well just type it here. We're in a classroom example. So it costs $1.25 to add pepperoni in there. When I was jotting down the plan, I did pepperoni pizza, a cheese pizza, and a supreme pizza. So supreme would also have green peppers and mushrooms, so we'll need those toppings as well. I don't think we've done this. I'm gonna come over here into project settings. Instead of doing new and everything, I'm just gonna do copy and paste here. So I'm gonna copy the pepperoni, just normal Control C and Control V. And notice that it asks for a new class on, a new name for the class. So I'm gonna say green pepper. And notice there's a refactor button. So when it pastes that file in, since we have that restriction in Java, the very first class in the very first class in the file has to match the file name. It's a really easy thing to refactor and get all of that set up for us. And I'm thinking green peppers are probably cheaper than pepperoni, maybe 85 cents. Again, I'm just guessing the numbers. They're just numbers to do the calculation. If we had a full, realistic situation, we could probably do more. So I'll do that again. Over here, I'll hit Control V to paste and make mushrooms. I think mushrooms are cheap. I'll go with 90 cents on a mushroom. Just guessing, maybe they're more than green peppers. We're in the Midwest, so it's easier to grow green peppers here than mushrooms. Then good mushrooms, I guess fungi technically grow anywhere with no problem whatsoever. But the good ones that we actually want to put on pizza and stuff, those take more special care. I'll give us a couple toppings and we can just keep adding that and figure out the price for each one. I think y'all see where that pattern would go. So lots of different toppings that would just extend, and there's nothing new added on there, just new price for each one. Should kind of make sense. Since everything would have a price, we could set it up here with different set up data fields in the parent objects and all that, but kind of shortening things out. In a real restaurant situation, you might want things like how much does it weigh, how long is it good for. In the modern world, you might need some different things like how does it affect cooking time? Yeah. We're used to mass-produced pizzas in America, but if you go to a really nice pizza place where they cook them one at a time in a brick oven, there's a big difference in properly cooking a pizza that has like one single meat on it or a bunch of meats, because there's a different amount of grease. That's going to change how everything cooks. Some vegetables are have a lot more moisture than others. That's going to affect cooking time. So little things like that if we went to like a fully automated pizza place, we might want the machine to be aware of, because the machine could handle things like that quite easily. Make those little adjustments. In the mass-produced Pizza Hut, Domino's, Papa John's, when I've worked at all three, generally if there was something like somebody ordered double of every topping, we just push it back halfway through the oven. And it goes through at the same speed as everything else. And it's like, whoa, that's a lot of toppings. There's no way that thing's good. We just kind of push it back a little so that it gets another couple more minutes. And it's generic places. Lots of different things we can put on pizzas. Everybody has different tastes, and people have very, very strong opinions on some of the toppings. It's very interesting about pizza toppings too. Unlike other food, people actually complain about most foods. People just won't eat the things they don't like. But with pizza, people actively complain when they see somebody else eating toppings they don't like on a pizza. So our pizza pie will have toppings. plural, so probably a bunch of them, so we need some sort of list. Array list, linked list, I think I'm gonna go with a linked list. We used array list last couple times. There are subtle differences as when one would be better than another in a given situation, but until things get big, it has to get pretty big before it makes a difference. And really what I was thinking with linked list is array list grows quicker. Remember the linked list, we just add another one every time. So it's basically growing linearly. But array list, once it hits a certain size, it gets bigger. And once it hits another size, it gets bigger. Array vectors double every time. And array lists have they grow at different sizes. There's different things, but array list grows quicker because it makes room for like a whole nother array. Linked list where it just grows one at a time, and we're not going to add 8 more toppings at a time. Right? 8 toppings is a lot for a pizza, so I think a linked list would be a better option in this case. But in general, until it gets fairly large, it's going to be a matter of preference as far as what you prefer to work with. What makes more sense in your mind when you're visualizing things. When it comes to debugging, initially writing the code is easy. But when you hit problems, you have to think about it in different ways, right? It's like, okay, you hit a bug, got to fix that. It's like, okay, obviously my initial thoughts were wrong. I have to change my perspective and adjust for all of that. Y'all are familiar with that system or that process. Call this toppings. There's a new linked list, and toppings can be implied here. And I'm just going to do the auto imports. Again, that thing, computers are better than typing at humans. So we have a crust, cheese, sauce, toppings. We'll have to calculate price. That's in our interface. We can't actually use this one, so it has to be going to have to be until we set up that interface. So we know we'll have the price. Anything else we need for a pizza? That sounds like, I'm thinking that sounds good for a start. It can be extended afterwards, right? We do want to try to fit this into a class period with time to extend it afterwards. So I'll go ahead and insert the constructors. An empty constructor. I'm just going to do an empty constructor every time. Well, actually, I'm going to do, instead of doing a full constructor, because we'll have, obviously going to have all the getters and setters here shortly. Whenever the first thing we want to know before we do anything else is what type of crust we have, right? So we could probably put that in our constructor. Like, what type of crust is it? And that would be a choice from a short list. Actually, I'm going back and forth. I'm going back to my original plan. I'm just going to do an empty constructor and do everything else with getters and setters. Because I'm thinking we're going to run short on time to actually make a GUI and like an HTML page or something. But remember, our setting was only going to be one line, so you could just put this in an HTML page and move the stuff right over with no problem. So my original plan was do the pie and then do menu driven when we place the order. Like, what type of crust do you want? 1, 2, 3, or 4. Enter. Here's the menu of toppings. What do you want to do? I think everybody's seen menu driven stuff. That's quick and easy and nice in classroom examples. Even though GUIs look much better, they just take a while But logically, the same thing happens. Do we click a button or do we type 1, 2, 3, or 4 for that option on the menu? So now our getters and setters, which in NetBeans, again, Alt insert, and we can grab all our getters and setters at once. And most all IDEs will have, since getters and setters are pretty much always the same, it's gonna be like that. Yeah, I had a feeling it was gonna use the word is. I'm gonna change the is to has for the cheese and the sauce. Oh, yes, we will look at that soon, Mark, in the chat room. That a question about installing Java FX. It's just an external library. It'll be the same as what we look at Wednesday. We just download, we just have to reference that library in our command prompt. Actually, I can show you in 2 seconds here. When you click on the package name or click on the project and go to properties, pretty much the same in any IDE, Eclipse, or wherever you set up the properties. There would be something similar in VS Code, wherever you're setting up things. Somewhere there is a thing called module path under libraries, an option where you're looking at libraries, and you just add it to the module path. Or in the command prompt, when you compile it, Java C -- module path. Oh, -- module dot path, and then wherever the path is, like C, I guess users, downloads. So wherever you put it at, you just add it there, and then the Java file. So somewhere on your GUI will be an option to enter that module, to set up the module path. That's what we're going to look at Wednesday, and it'll be exactly the same for any of the official modules not included in the official installation. So what we do with MySQL will be exactly the same for Java FX, except for where we download it from. I had to think for a second about Java FX. I think we will have time to see a better way to do that too. Because the preferred version of it is FXML. The preferred version is to use a markup language version of it instead of the Java syntax, which has a really, really, really nice drag and drop interface to put it together. We will see both of them. I think we're going to spend 2 or 3 weeks on it, so there'll be plenty of time to see both of them. Back to our example. But yeah, it'll be exactly the same as what we do Wednesday. So a change, yeah, and just to make those words make more sense. Little things like that. Everything here should be looking very familiar, right? Anybody see anything that just utterly confuses you? Oh, whoops. Oh, so there's a little side note about the thing. I don't think it's shown up for you, Mark. I see those a lot. So in the chat room, don't want to turn in a progress report that says hasn't started yet. But what have you not started? You haven't started typing. But typing is not programming. Typing has nothing to do with programming. Really, this is becoming outdated in the modern world. Typing's an old style way of doing it. You've done the thinking, and that's what it is. It's a thinking thing. planning, strategy. So you have started, you just haven't done the typing part, and that's just tedious, busy work at the end. There is software that we can just have it listen to the team talk about the program it wants to make, and it will write all the code for you. The text is just extra little things. That's really neat when it's what do I look at it? It's a French word. I don't try to pronounce French names. However you pronounce that in French, you can take that and the standard tie-in to audio sensing. I'm forgetting the letters. TFFT. Ah, there it is. Nope. TFT audio AI. I'm forgetting the letters. Whatever the standard tie-in for things like Google Assistant, Siri, Alexa, all of them. There's 5 letters to it, and there's 2 T's and an F, and then some other letters. And I'm drawing a blank on it. But you tie that into this thing, and it can just listen to you talk. Listen to the developers talk about it and put together the program you want. The only thing the AI can't do is develop an algorithm. So as far as the progress report goes, all you really haven't started typing. But in general, most of the work should be done before you start typing. Because programming is not a typing thing. There are different ways to do it, but programming is about thinking and planning and figuring out what to do. So we will see that soon. When does the progress report due? Isn't it module 6? We will see it before then. November 8th, so yeah. We'll be into the module on Java next by then. But your classes need to be separate from the GUI anyway. The only thing the GUI is going to do is call the other stuff. So you can start putting them together in like this. We're going to run out of time from definitely not have time to make a GUI tonight. So this one's just going to go to the console, and then we can put a GUI on it and it'll do the exact same thing. The background and foreground will be separate. Right? That's why we always use those terms. Front end developer, back end developer. They're completely separate. So we can do the whole back end. I think we have seen all the pieces to do the entire back end for your project. And then all that's left is the front end. Does that help, Mark? Make you feel a little better about it? It will be exactly, external modules are exactly what we will see on Wednesday. Because you also should need a database on your project too, which that is explicitly what we're seeing next week. But yeah, all of the stuff like this tonight, that's why I wanted to do this, because we're ready to do the full back end. And we can spit out the test cases to the console, and then all we have to do is have the GUI call the methods we make here. If everything is modularized correctly, which is what the interface is about. Set up an interface, and that has all of the connections, like a plug. Yeah, I don't think it's going to show on the camera. Here's like a physical example of like the KVM switch here on the desk in front of me. It has all the connections, so no matter what somebody comes in with, old PS1 style plugs, USB. I'm guessing one of those is USB 3 and one of them is USB 2, but I don't see any labels. I don't know of another reason why it would be color coded. I believe they're both USB 2. It's hard to tell from looking. That's better stuff inside the wires, but all of the stuff necessary to connect to a computer. That's what an interface is. So you can go ahead and make that part, and then you have everything ready for. Then you have everything ready for your GUI to plug into whenever you make the GUI. And that part's really easy. That's just like, where does the button sit on here? Where does the button sit? What XY coordinates is it? And then what part of the interface does that button plug into? Let's see, what else might we need? Okay, so back to our example tonight. I have one more option on the list here that we would need, because we're gonna have a list of toppings. So we probably want a method to add individual things to the list. Because when we did getters and setters, all we got was the thing to return the entire list at once, or change the entire list at once. So we probably want something to add toppings on. Yeah, I'll do this. Well, we'll just call it one at a time, add topping. It'll be one of our topping data types. Really the childs of that. I'll just call it that. And what about this method? Are we ready to make this method? So let's look back to the other camera real quick. I think I have to stop screen share here. In the messy plan, it looked like a mess, but is this still on? Basically two types of toppings here, or two types of pizzas. Either specialty pizzas or custom pizzas. And anything on the specialty side, that's going to go in kind of like the magic numbers we did for the price, right? If somebody orders a pepperoni pizza, we know what goes on there. Somebody orders a supreme pizza, we know what goes on there. Versus somebody calls up and they want ham, mushroom, and pineapple, a Hawaiian pizza. I guess that would be a specialty pizza. And anchovies, that'd be a unique thing. We'd add the toppings separately than we would for each one alone. Did I switch cameras again? Okay. So that was my thought for an abstract method versus the interface method. Share screen. Does that sound clear as to like the difference between them? Because in the interface we have that pricing one, and that's how we're going to use what we're going to use to connect things together. Add topping is a little bit different because only the pizzas have that, and at this point we just don't know how to fill that out. So this would be an abstract method in the parent class rather than the interface, where it's a requirement in order to connect things together. I was expecting something there. Public After that abstract, do we need to return anything? It's just gonna go on the list. I don't think we would. I'll just do a void, but oftentimes it's good to do, well, what we're gonna see a lot on Wednesday. For those who've had SQL class, you might remember whenever we run a SQL query, jumping ahead to what we're gonna look at Wednesday, we always get something back, right? We either get back the number of rows, like an insert query, we get back the number of rows inserted, or we get back a -1. If we run a select query, we get back the number of rows that pulled, or we get back a -1. So sending some type of return, and then we can call that method from an if else block can be very useful. But also it's usually really easy logic to visualize, so it's just kind of extra time consuming in classroom examples like this. So kind of everything we've seen over the last couple weeks, right? That's what I was wanting, and you see how the pieces fit together. Because we have multiple types of abstract methods going together to create an abstract class. And there's different places where we would use each one. Is it what we use to connect pieces together? Or is it just something we don't have enough information to fill out yet? Because I believe our textbook was one of the ones that left that very ambiguous, and they just used abstract methods all interchangeably. But we kind of have two different versions of abstract, or of when things need to be abstract. So I think we're ready to make the other two types of pizzas where we're actually, the ones we'll actually be able to place an order for. And then place an order, which means it's probably a good time for a break. I'm guessing, okay, 2 more classes, and then a menu-driven thing to all those classes. I'm thinking half an hour or so, 45 minutes, maybe. But it's probably a good time for a break because we're an hour, right? An hour staring at the screen. Remember, staring at screens is bad for our eyes. It's not the best thing for humans. You always want to step away periodically. Just 10 minutes sound good to everybody? I see big head nods here in the class. My laptop says 7:05, so we'll get back to it at 7:50.